Alright, so we're going to add the work to this example on a sheet of paper. Use the same sheet of paper that we have our rectangles from the beginning of this note. So the last thing is very important because we're going to have to prove some things with coordinate geometry whenever we have coordinates that are not numbers, when we have variables. So make sure you start off with drawing a diagram. This one's already given for you. So I would probably trace this over to your sheet of paper. And then we are going to need to make sure we know our given and our proven statements. That's what we have here. We're going to be given that M is the midpoint of PQ and N is the midpoint of QR. We're going to prove that if it's using that we have a mid-segment theorem, basically, that the mid-segment is parallel to the third side, and it's going to be half of its length. Okay, so this is important. What I have started here is step 3, knowing these 3 bullets, and that's what we're going to apply. We're going to do each one. So I just kind of copied our figure, and we're going to show the work for each one. So the first thing is we got to find that midpoint formula. We got to use the midpoint formula to find the coordinates that we have here for M. Okay, our midpoint formula basically is just our x1 plus x2, the average of our x's because we're divided by 2, and y1 plus y2, which is on your formula chart. Okay, so what we're going to do, use this formula to find the coordinate of M. Now remember, we have different variables to represent the coordinates, but okay, our order pair is always x and y. So I'm just going to add my x's. So for M, to find the coordinate of M, I'm using side PQ, so I need to use Q and P, which is 0 plus a negative 2a divided by 2, and then we have 2b plus 0 divided by 2. All right, so I'm going to simplify that. I'll show each step. I think some of you might have seen it already. Anything plus 0, we know it's just going to, it's your addition identity. So and we have 2b over 2. And we should probably, some of you probably already saw that. You just skipped a step and saw that you can simplify that. So this was a negative a comma b. So we're going to go ahead and put that coordinate. So I'm going to erase this right here. We're going to put that coordinate for M. So negative a comma b. We're going to do the same thing for N. Okay? We need to find that coordinate of N. So we're going to do average of x's, so 0 plus 2c divided by 2, and average of the y's, 2b plus 0 divided by 2. Simplify, some of you already saw. We're going to get basically c comma b. All right, we're going to go ahead and add that in our drawing. C comma b. So that takes care of the first step. We need those midpoints to determine if the slopes are parallel. And we're going to use a slope formula for that. Our slope formula is basically our delta y over delta x, which is our change in our y coordinates. y2, excuse me. Fix that y2 minus y1. Over our x coordinates. Okay? That's our little lowercase, our slope. So we're going to start off with finding the slope of MN. Okay? We're going to calculate that. We got to check, see if it has the same value as PR. That's the first thing we're trying to prove, that they're parallel. So changing the y values, okay, that would be b minus b, and the change in the x values would be c minus the negative a. Well, b minus b is 0. This ends up being c plus a. But we should know that anything, when we take 0 and divide it by anything, okay, we should always end up with 0. So the slope of MN equals 0. Now we're going to check the slope of PR. We need to show that they have the same value to show same slope. Therefore, exactamundos parallel. So we got slope of PR. We're going to do the change in the y value. So that's just 0 minus 0. Or the change of the x, that's 2c minus the negative 2a. Well, 0. And basically we have 2c plus 2a. Okay. And again, this is going to end up being, yes, just 0. Okay. So now I'm showing that they have the same slope. Okay. So I can make a conclusion here. The slope of MN equals the slope of PR. Therefore, segment MN is parallel to PR. If they have the same slope, then they are parallel. So I'm going to go ahead and add my arrows now to show, because I proved it. I have the value of each. And I know you're looking at it and you're saying, well, those are two horizontal lines. Of course their slope is 0. But don't assume, especially when we're doing with variables that are other letters, okay, that are not numbers. And then our last and final step is we're going to take that value. So I'm going to go ahead and add what we just did before. Make this a little bigger. So what we had before, we had our value of our coordinates of M, which were negative A and B. And we had the coordinates of N, which was C and B. And we knew slope of MN was parallel to the slope of PR. So the last thing we have to do is now we got to look at their distance. Okay? So we're going to use the distance formula. Distance formula on your formula chart, which you know right now, x2 minus x1 parentheses squared equals y2 minus y1 parentheses squared. Now we're going to just plug in these variables that we have for each segment. So we're going to start off with our MN, and we're going to simplify it. So in the first set of parentheses, we're doing our x2 minus x1, so we got c minus a negative a. Close the parentheses square. Then our y's, we have b minus b. And then we know what happens there, right? Okay, 0, 0 squared. Okay, you should know what that is. 0. All right, so we're going to go ahead and just simplify. So mn equals the square root of c plus a parentheses square. Now, I want us to talk about two things. Let's say we wanted to show this binomial squared as a trinomial. This is when we go back to our box method. But let's think about this. If I'm taking the square root of something that's raised to a power of 2, okay? I'm doing basically taking the square root is taking the inverse. I'm hoping we see that this would end up getting simplified as c plus a. Okay? C plus a. So it's like saying, okay, what if I had 3 and I square it? And well, 3 squared is 9, and I take the square root of that. Well, the square root of 9 is 3. So if I just do it at the beginning, I'm basically getting rid of my exponent, and I'm just left with inside. This is what we had inside that expression. Okay, it's just doing some reasoning with number sense. Okay. All right. So now we're going to find the distance of PR. Do the same thing because we've got to compare them. So we're going to do the difference of the x values. So we're going to have 2c minus a negative 2a parentheses square plus, well, we know what 0 minus 0 is. So we're going to simplify this. And I'm hoping we see that PR is now 2c plus 2a parentheses squared. All right, I'm going to simplify this just a little further. Or just kind of do what we know. Take the square root. This ends up being 2c plus 2a. Well, they have a 2 in common. So I'm going to factor that out. So we got 2 times c plus a. So look at this. First we had c plus a, right? Now we have 2 times c plus a. What did we do? What are we showing here? Right there. It's twice its distance, okay? Because I see that, I'm now proving, think about it. If I'm now showing you that 2 times c plus a is basically half of, or 2 times c plus a, for it to equal mn, I would have to double what mn is, right? We have to times it by 2 for it to be equal. Well, if I take half of it to get rid of that fraction, right, I'm going to be left with just the c plus a, which is what the mn was. So I'm now showing you that these two are parallel and that half of mn, or so half of, excuse me, PR equals mn, which is what we were trying to prove. And so that's our final step. Our final step is always seeing that at least one is double the other, because this would be like a coefficient of 1. And if we see that, then I know that's definitely a mid segment. Okay? So that takes care of problem 12. Now, let's get to problem 13. Again, you're going to have to use your sheet of paper. We're going to have to do some drawing here. You're going to have to sketch. Now, we have to draw an isosceles trapezoid with a height of 2h, a base of 2a, and a base of 2b, so that at the origin is the midpoint of the bases and the length 2b. So, start off with your x and y axes. Okay? Doesn't have to be perfect. But this is key. We're going to be at the origin, okay, is the midpoint of the base with length 2b. So that means the midpoint. So that means the distance between the two. I'm going to make my trapezoid green. Let's put this here. Between my 2 points, that's almost about the same, okay, is equal distance from our y-axis. So let's just say I make this, and now we're going to try and make this isosceles trapezoid. So if this whole distance between them is the 2b, that means each side has a length of b. Okay. So let's just, with that being, that's going to be one of our bases. So we want it to be an isosceles trapezoid. So the two legs have to be the same. Let me fix the second leg here. Oh man. Hold on. Okay, get back to where, sorry, it froze up on me. So now we know one of our bases, the bottom base is 2b, the top base has to be 2a, so that means that each segment here has a length of a, okay, a length of a. So they want us, there's a corner, vertice, a vertice. The first thing they want us to do was to draw it and label it, okay, and then our height of our trapezoid is the distance between the bases, and it's your perpendicular distance. So I know the y-axis, and it's going through the origin. It's perpendicular to the x-axis. So that height right there is going to be 2h. Okay, the height is going to be 2h. So they want us to give the coordinates of the vertices for the trapezoid. So since it's at the origin, we have reflexive. Okay, so that's equal distance from that origin, and we have points of symmetry. So I'm going to let's get this labeled first. Let's go ahead and just say we have T, R, trap. Okay. All right. So our T would have what coordinate? Think about that. Distance from the y-axis to basic to the left, and it has a height. Our vertical distance is h, 2h. So hopefully we see that we have negative a, comma 2h. Okay. And then our coordinate. Now you got this. We got a, comma 2h. And then our a coordinate, okay, that's our b there. So b, 0. And then our p coordinate is negative b, comma 0. Sorry about that. It looks kind of messy. Let's see, maybe I can move this over. Alright, that's a little bit better. Okay, alright, so now, part C, they want us to compute the lengths of the legs of the trapezoid. Alright, so because they want us to find this length, okay, that means we got to find the distance. That means we're going to use our distance formula. So we're going to find the distance of TP, alright, and the distance of RA. Now, anytime I write the letters side by side, that's showing that I'm finding its length, I'm finding its distance. So we're just going to plug it into our distance formula. And we're going to use the coordinates that we have for T and P. Changes in Y over change of X. So minus B, a negative B, minus a negative a, parentheses squared, plus, okay, so we do a change in y. So that's just our 0. I know that looks like 2b, but that should be 2h, right? Yeah. 0 minus 2h. This should be an h right there. All right, and parentheses squared. And we're going to simplify that. And so I know I'm about to run out of room. So I'm just going to simplify TP over here. So basically I have a negative b plus a parentheses squared, and then in my parentheses 0 minus basically negative 2h parentheses squared, and that should be a plus sign. And then if I simplify this some more, well, I'm going to keep, I'll show you in a bit, but I'm going to keep that as a negative b plus a parentheses squared. And I know when I square a term, I square the coefficient, which is our negative 2, and I square that variable. So this now becomes plus, the negative 2 squared is always going to be a positive. So we get plus 4h squared, all underneath the radical. Now, we're going to do the same thing for RA. Okay, and this is our TP. We're going to do the same thing for RA. I'm going to scroll this up just a little bit. So we're proving our leg. So here's RA. Okay, I'm going to use the distance formula with their coordinates R and A. So basically have B minus A parentheses squared, and then plus 0 minus 2h parentheses squared. Now I'm just going to simplify. We have B minus A parentheses squared plus again 4h squared. Okay, now let's look at these. Because this is RA, is this expression right here the same as this expression right here? Okay, are they the same? Maybe you're thinking, that should be something, right? Let's think about it. Well, let's just check. Let's just check. Let's make sure you see that a negative b plus a squared and b minus a squared would give me the same expression. I want to see y'all can explain why on Monday. But if I was to use my box method, let me just check. Just basically simplify the expression. Negative b and a, negative b, because that means the exponent of 2 doesn't we have two factors of that. So let's just go ahead and work that out. So negative b times a negative b, positive b squared. Negative b times a, negative ba. A times a negative b, negative ba. A times a squared. If I combine my like terms, I have basically b squared minus 2ab plus a squared. Well, if I check that with my other expression using the box method. So here we have b negative a, b negative a, b squared, negative ba, negative ba, positive a squared. Look what happens here. 2ab plus a squared. Yeah, some of you saw that. Why is that? That's what I'm going to check. See if you can tell me on Monday. So these are the same. So if I know that I have the same expression underneath, then I know that these two legs are congruent. Okay. So now, if I have two congruent legs, okay, we have an isosceles trapezoid, hopefully. Yeah, because they have to be congruent for it to be isosceles. Now, the last thing, or the last two things, is that one is to find the slope. You're definitely going to be asked to do something like this on your test on Thursday. So we're going to find the slope of the two legs of the trapezoid. Well, that's when we're just going to do the formula that we did on number 12, where we did delta y over delta x, okay? So we're going to do the slope of TP. Look at the ratio. So change in y over change of x. So basically 0 minus 2h over our negative b minus a negative a. We're going to simplify that. We get a negative 2h, okay? And then we get negative b plus a, okay? So there is our ratio. Now, about a negative divided by a negative, okay? We could say if we plot the negative 1 out, then yeah. But let's just check the ratio. Let's just see if we get the same one. So then we're going to do the same thing for the slope of RA, okay? Slope of RA, change in y, change of x, that's y over delta x. We have 0 minus 2h. Ooh, that looks familiar. And then we have b minus a. Oh, we just talked about that. Okay. So we got negative 2h over b minus a. Are these the same? That's our question. Yeah, they are. We just talked about basically what's happening here. If I have a negative b plus a, is that the same as b minus a? How do I make that the same? Multiplicative identity. That's your clue. All right. And then the last thing we want to check is we want to check the midpoints. Okay, we want to check the midpoints. Now, let's talk about this distributing of this negative b plus a. I'm hoping we're seeing that basically eventually they would just intersect because they're opposite of each other. I just realized that this one only had the negative with the b. So it's a little different than squaring it. And every time you square something, it becomes positive. This is not being squared. So these are just going to intersect. This is showing right here with that negative sign right there and that this one ends up becoming positive. And then this one here, when we show ends up becoming negative, whenever we have opposite slopes, then they're just going to intersect. All right, midpoint. Let's do this in red. Midpoint formula. And I'm going to just do it. So we're going to find the midpoint of the legs of the trapezoid. That means the midpoint of TP. So you got to use the TP to find your M. All right, so basically negative A plus A divided by 2. Oh, that's R. P. Should be using P. Negative A plus negative B divided by 2. And then we have 2H plus 0 divided by 2. Now, these are not like terms, so I can't simplify this. I can't combine them. So basically, our midpoint is a negative a plus negative b divided by 2. But I can simplify this, and that just becomes h. Okay? So there is our coordinate for our m. I'm going to make that m. And I'm going to make the other one, let's just make it x. Okay? And we have to find the midpoint from not t, from, what is it? RA? Yeah, RA. So I'm going to make that x. To do that, we're going to be doing a plus b. Make sure that was right. Yeah, a plus b divided by 2, and then 0 plus 2h divided by 2. And then we simplify that. That has to stay the same. A plus b over 2 has to stay. But we simplify this to just h. Okay, and that is our x. And doing the following, basically doing what we just did for B, C, D, and E, is what you're going to have to show and prove and verify when dealing with coordinates other than x and y, other than actual numbers using variables. All right, thanks for taking care of this. Be ready to practice. Things are changing. We're going to review that a little bit on Monday. Have a good weekend.